Yes, it is permissible to use one cable for both a 24 volts DC power supply and a 2-wire twisted pair designated for digital data return, provided several critical conditions are rigorously met. Firstly, ensure strict conformance to Class 1 wiring standards. The cable itself and its installation must comprehensively fulfill the requirements stipulated for Class 1 wiring. These requirements are specifically designed for low voltage, non-power limited circuits, necessitating careful adherence to ensure safety and compliance. Secondly, implement separate conductors within the cable. A 24 volts DC power supply and a 2-wire twisted pair must be run in distinct isolated conductors within the cable assembly. This physical separation is crucial to mitigate electrical interference between the power and data signals, which can compromise data integrity and system performance. Thirdly, ensure proper shielding to minimize electromagnetic interference, or EMI. The twisted pair employed for data transmission should be adequately shielded to attenuate any external electromagnetic noise. Critically, the shield must be grounded at one end to effectively drain away any induced noise or interference, preventing it from corrupting the data signal. Fourthly, select a sufficient wire gauge for both the power conductors and the twisted pair. The wire gauge must be appropriately sized to accommodate the specific current and voltage requirements of both the power supply and data transmission circuits. Consultation with a qualified electrician is strongly advised to ascertain the correct wire size, ensuring safe and reliable operation while preventing overheating and potential hazards. Fifthly, always comply with all applicable electrical codes and regulations. The installation must rigorously adhere to all relevant local, regional, and national electrical codes and regulations. Compliance ensures safety, prevents potential hazards, and guarantees that the installation meets the required standards for performance and reliability. The benefits of using one cable are, firstly, cost savings. Opting for a single cable instead of separate cables for power and data can significantly reduce both material and labor costs associated with wiring the system, leading to substantial economic advantages. Secondly, simplified installation. Consolidating all necessary wires into a single cable streamlines the installation process, making it easier and less time-consuming to deploy the system, ultimately reducing labor hours and project timelines. Thirdly, reduce cable clutter. Utilizing a single cable minimizes cable clutter in the installation area, resulting in a cleaner, more organized, and more manageable wiring environment. This enhances maintainability and reduces the risk of accidental damage to cables. An example of a suitable cable for this application would be a shielded, twisted pair cable incorporating 4 conductors. This configuration typically includes 2 conductors dedicated to the 24 volts DC power supply and 2 shielded twisted pairs specifically for the digital data return. Additional considerations include, firstly, ensuring equipment compatibility. Verify that the power supply and the digital data equipment are fully compatible with the voltage and current levels being used. Incompatibility can lead to equipment malfunction or damage. Secondly, use a surge protector or transient voltage suppressor, or TVS. Consider incorporating a surge protector or transient voltage suppressor to safeguard the equipment from voltage spikes or surges, which can damage sensitive electronic components. For Class 1 wiring, refer to the National Electrical Code, specifically Article 725, which covers Class 1, Class 2, and Class 3 remote control, signaling, and power limited circuits. The specific sections within Article 725 relevant to your application will depend on the specific characteristics of your circuit. However, some generally applicable sections include 725.1, which covers scope. This section defines what Article 725 covers, including remote control, signaling, and power limited circuits. 725.3 covers locations. This section details where Class 1, Class 2, and Class 3 circuits are permitted and not permitted. 725.21 covers Class 1 circuit wiring methods. This section specifies the wiring methods that are permitted for Class 1 circuits. 725.25 covers conductors. This section specifies the types of conductors that are permitted for Class 1 circuits, including the allowable ampacity. 725.27 covers overcurrent protection. This section specifies the overcurrent protection requirements for Class 1 circuits. 725.52 covers wiring methods on supply side. This section covers wiring methods for Class 2 and Class 3 circuits on the supply side of the power source. For conductor ampacity, refer to NEC Table 310.15b16, formerly Table 310.16, for allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius. The appropriate ampacity will depend on the conductor material, insulation type, and ambient temperature. For example, if you are using a copper conductor with THHN insulation in an ambient temperature of 30 degrees Celsius, the allowable ampacity for a 14 American wire gauge conductor is 20 amps, a 12 American wire gauge conductor is 25 amps, and a 10 American wire gauge conductor is 30 amps. The 24 volts DC power supply. It's critical to remember that even low voltage circuits can pose risks if not properly designed and installed. A short circuit can still cause a fire or other damage. Always use appropriately sized conductors and overcurrent protection devices such as fuses or circuit breakers. Regarding the two-wire twisted pair for digital data return, selecting the correct type of twisted pair cable is important. Unshielded twisted pair, or UP, is commonly used for data transmission, but in environments with significant electromagnetic interference, shielded twisted pair, or STP, is recommended. STP cables have a metallic shield that helps to protect the data signals from external noise. When grounding the shield of the STP cable, it is generally recommended to ground it at only one end, typically at the source of the equipment end. Grounding at both ends can create a ground loop, which can introduce noise into the system. To further minimize the risk of interference, consider using a cable with individually shielded pairs. This provides additional protection against crosstalk and EMI. Also, ensure that the data cable is kept separate from high voltage power cables whenever possible to minimize the risk of interference. When running the cable, avoid sharp bends, as these can damage the conductors or shielding and degrade performance. Use cable ties or other supports to keep the cable properly organized and supported. Ensure the cable is adequately supported to prevent excessive strain on the connection. The connectors used for the data cable should be appropriate for the cable type and application. Ensure that the connectors are properly installed and terminated to provide a reliable connection. Using high-quality connectors and termination tools is essential for ensuring good performance. To ensure proper grounding, connect the shield to a suitable ground point on the equipment or grounding system. Verify the ground connection with a multimeter to ensure it has a low resistance to earth. Consider using a dedicated ground wire for the shield to provide a reliable ground path. Regarding compliance with electrical codes, always consult the latest edition of the National Electrical Code, (NEC), and any applicable local codes for specific requirements. Ensure that all wiring and equipment are installed in accordance with these codes to ensure safety and compliance. Obtain any necessary permits and inspections to verify that the installation meets the required standards. Keep detailed records of all wiring and equipment, including cable types, conductor sizes, overcurrent protection devices, and grounding connections. This information will be helpful for troubleshooting and maintenance. A qualified electrician should perform all electrical work to ensure it is done safely and in accordance with applicable codes. A qualified electrician has the knowledge, skills, and experience to design and install electrical systems safely and reliably. Using one cable can simplify installation and reduce clutter. It's essential to consider the potential drawbacks, such as increased complexity in troubleshooting. If there is a problem with either the power or data circuit, it may be more difficult to isolate the issue when both circuits are combined in a single cable. If the power and data circuits have significantly different voltage or current requirements, it may be necessary to use a larger cable than would be required for either circuit alone. This can increase the cost and weight of the cable. If the cable is damaged, both the power and data circuits will be affected. This could result in a complete system failure. Implementing proper surge protection is important to protect equipment from voltage spikes and surges. Surge protection devices, or SPDs, are designed to divert excess voltage away from sensitive equipment. Install SPD at the service entrance and at the equipment itself to provide comprehensive protection. Ensure that the SPD are properly grounded to provide an effective path for the surge current. Regularly inspect SPD to ensure they are functioning correctly and replace them as needed. In areas prone to lightning strikes, consider using lightning arresters to provide additional protection. Use a transient voltage suppressor to protect the equipment from voltage spikes or surges. A transient voltage suppressor, or TVS, is a semiconductor device designed to protect electronic circuits from voltage spikes. TVS diodes are commonly used to protect sensitive components from electrostatic discharge, or ESD, and other transient voltage events. Select a TVS diode with a breakdown voltage slightly higher than the normal operating voltage of the circuit. Ensure that the TVS diode has a sufficient surge current rating to handle the expected transient currents. Connect the TVS diode as close as possible to the protected component to minimize lead inductance. Regarding cost savings, using one cable instead of two can reduce the material costs, as you only need to purchase one cable instead of two. This can also reduce labor costs, as it takes less time to install one cable than two. In addition, using one cable can reduce the amount of cable clutter in the installation area, making it easier to maintain and troubleshoot the system. By running all the wires in a single cable, the installation process is easier and less time-consuming. This can save time and money on labor costs. It can also make it easier to route the cable through tight spaces. Using one cable reduces the amount of cable clutter in the installation area, making it easier to maintain and troubleshoot the system. This can also improve the appearance of the installation. Always consult with a qualified electrician or electrical engineer to ensure that the wiring system meets all applicable codes and standards. A qualified professional can help you select the appropriate cable and components for your application and ensure that the system is installed safely and reliably. When selecting a cable for this application, consider the following factors. The cable should be rated for the appropriate voltage and current levels. The cable should be shielded to minimize electromagnetic interference. The cable should be flexible enough to be easily routed through tight spaces. The cable should be durable enough to withstand the environmental conditions in the installation area. Proper planning, careful selection of components, and adherence to electrical codes are essential for ensuring a safe and reliable installation. Regular inspection and maintenance are also important for maintaining the long-term performance of the system. Finally, always prioritize safety when working with electrical systems.